After we know about the literals and the expressions as a part of machine independent assembler features, next let us move on to the program blocks. Under the program blocks, or before you see about the program blocks, till now we had used so many programs wherein complete main code that you call as a main routine, subroutines, and also data areas, everything which was put it as a single program block. So wherein there is a possibility where you can have in the different sections or different subroutines or different pieces, so wherein you can have a separate instruction code separately and the data area can be a separately. How to deal with such kind of pieces where you have a instructions related to the program may be different and also the data instructions related to the data may be different. If you how to have it separately and how to make it happen, for that purpose itself where we'll be dealing today about the two very important concepts. You call it as one is program blocks and the control sections. First, let us see about the program blocks. What is the program block in the sense? However, the name itself specifies it's a block of the program. It's a block of the program which is kept in a different location, different pieces, different place. So you treat each block of the code or a block of the program differently instead of it as a single. Instead of you consider as a whole code, instead of you consider as a whole program, you try to consider in the different way. It is as same as the machine instructions and also the data to be appeared whatever in the object program should be can be in the different order, need not be in the continuous order, so that whatever the program code which is created in the object program can be from the different independent parts, need not be from the together code. So that is what the program block. Now let us see the example here as such. So here is an example where this is the here we have the three main routines, or I can say there are three program blocks, I can say, or you can call it as a two subroutines and main routines. As such, this is the main routine and there are two subroutines. This is the read record of one subroutine and the next it is the write record is the other subroutine. So among these three pieces of a program, so we are going to use the concept of program block. How exactly? In the sense, even before we see about the program block, this is where you can observe this read record and the write record are the two subroutines we are using in this example. Both can be called just by using the jsub instruction, wherein you are calling the jsub read record and the write records by using the jsub. And very importantly, these instructions are not the format 4 instructions however we used earlier. Right now you can make use of these as a format 3 instructions itself by the use of this program block. How? Let us justify further. Even before this, you can observe right here, there is a separate or one more new assembly directive which has come across for you guys. It is the use keyword. If you observe right here, this use keyword, it means to say that whenever you have a use followed by any name, it means to say that this is the separate program block, which is C data is a separate program block. Any instructions followed by that, all those are belongs to that program block. So in this example, as we have use followed by C data, here C data is one of the program block name and there are two instructions. These are the two instructions belongs to that program block. And there is one more use followed by C blocks. I call it as a C blocks. I call it as a C blocks. It is CBLKS. I call it as C blocks. So here these are the few more instructions. I call it as a 3 more instructions belongs to this program block, which is C block. So in this example, if you observe, so this is the main block, there is the main program block, and this is the one of the sub program block which I called as a C data, and this is the one more program block which is C blocks. Now whenever you have a use followed by a keyword, then it means to say that it is belongs to these further instructions belongs to that program block. What if there is only use like this? Use without the name in the operand. What exactly is this in the sense? Is it belongs to a separate program block in the sense? No. Whenever you have a use keyword followed by no name, if there is a use keyword followed by no name, then further instructions, followed instructions, all the followed instructions belongs to the main program block. This is the main program block till this j return address. So start from this copy start 0 till j return address. This is the main program block. So this main program block will be continued after this use till where? Till the rsub, because after rsub again we have use c data, which is the again appearance of the new program block, which is c data, wherein you can understand here already we have a c data, one of the program block. So here for the c data program block we have the two instructions here. So these two instructions will be followed by this instruction which belongs to the c data block. Again from the write record subroutine, again as usual, here you have a use followed by no name. As it is only use followed by no name, again further these set of instructions start from write record clear x till rsub. Again these instructions belongs to the main program block, because after that again we have use followed by c data and literal origin and end first. So these instructions again belongs to the c data program block. So if you observe from this, there are the three parts of the program. However, I said this is the main record, and this is the read record subroutine, and this is the write record subroutine. Out of these we figured out the three program blocks. Which are the three program blocks? One is the main program block, start from copy till j return address, again that is followed by read record till rsub, that is followed by write record clear x till rsub. That is the main program block. Again there is one sub program block, which is the c data, which has these two instructions. Again this is the instruction, again these instructions. Whereas the third program block, it is the c blocks, which has these are the three instructions. Like this we categorized into the three different program blocks. One is the main program block and the two sub program blocks. So totally there are three program blocks here. So once you come across with this program blocks, still you might not understand completely what is the use of it. You may understand further here. So this is the complete program which is generated by the programmer. Now as a assembler part of it, so as an assembler, what it's supposed to do? As usual, address assignment. So first step is taking the address assignment. Now you observe, as the start keyword has this address as 0, so you start assigning the addresses start from 0. Again as usual, all these are format 3 instructions, so you keep allocating 3 bytes to each. You observe right here, till this j return address we allocated 3 bytes to each instruction. Right after this j return address there is a initialization of the next program block, which is use c data. As there is a initialization of a new program block which is use c data, so the address assignment whatever we did for the main block, it will be resumed, or you can say it will be passed here at the 0024 for this j return address. So because these are all the instructions belongs to the main program block, for that let me call the program block number as 0. That is main program block. Right after this use c data, the new program block will be initialized from this c data, so the address will be again initialized back to the 0. And how many instructions are belongs to the c data? Here there are the 2 instructions. Again as usual, in the normal way of address assignment, this is what reserve word 1. So you will be reserving one word means 3 bytes, so it will be a 0 plus 3. Again for this length also you will be assigning 3. Then again right after this length reserve word 1, there is a initialization of a new block again, which is use c blocks, new program block. So address will be again initialized back to 0. Here if you observe, for these 3 instructions the program block number is 1. Again further for these instructions program block number is 2. Now suppose as here if you understand, so right here these are the two instructions which we set as program block 2, whereas even though we assigned the address for this max length, even though we assigned the address for this max length as 1000, but we did not consider this as a program block number 2. Why we did not consider this max length instruction as a block 2, that we are going to see further. I'll justify that in the further slides. So here you try to understand, you initialize the address to the 0 for the main program block, and you keep assigning the addresses as soon as you get the new program block. So your address is reassigned to the 0 and the block number now it is 1. Again when you get the one more new program block, address is initialized back to the 0. In this process again, let me continue for the next slide. As such, if you observe, so here as it has only use and it doesn't have the name, which I already told you in the previous slides, when you have only use without the name, so even these set of instructions also belongs to the main program block itself. So as these are also belongs to the main control block, now you see what was the last address after the last instruction address. It was 24, and this is also format 3. So as it is format 3, next address would be 27. So next address will be 27. So you keep assigning again. See again you see here these are the format 2 instructions. So you assign only 2 bytes. Again this is format 4 instructions, so assign 4 bytes. So likewise you keep continuing till this R sub, because right after this R sub again there is a UC data, which is again a new block or new program block. Now the point is that whether this UC data as soon as you got the here as UC data, this is the new program block. Now the point is that you need to find whether this C data is the initializing the new program block or it's already has. Now if you observe this C data which we had already here we had already, so for which we made the address started from 0 and we reached till 3. So again for this length as usual, length reserve word 1, where we'll be allocating 1 word of memory space. So it will be after this 3, next address would be 6. Next address would be 6 again, so that you understand clearly. So your next address is 6. Again you observe right here for the main block, for the main block, the last address was 24. Again that is continued here from 27 till 4a. Again in the next slide, again as usual, as it has a use followed by no name, so which already is said, use followed by no name, it means to say that these set of instructions belongs to the main routine itself. And again what was the last address? It was 4a. Again it is a format 3, 4a plus 3 you get as 4d. Again you keep assigning address assignment. This is the format 2, it's so assign 2 bytes. So 2 bytes, it will be 4d plus 2, it is 4f. Again you keep allocating based on the criteria whatever we followed for earlier. Again as usual, we came across again use C data. Again as usual, it is a means of new control section. So the control section number was 02. Again it is changed to 1 because it is a new control section. Sorry for that, it's a new program block. It's not a control section. Please try to rectify. It is a new program block. So the program block number was 0 and here it has changed to 1. So this is where now again as usual, what was the again you need to make sure that this new program block with the C data, you need to verify whether it is already available or not. As we know that it was already available earlier, it was already initialized here itself, which was the 0. Again it was incremented to till the 3. Again the next address we consider as 6. Again if you observe here, as it is a input byte f1 it requires only 1 byte. So as f1 requires only 1 byte, so after this 6, so the next address will be 7. Again you assign based on the requirement, you keep assigning. So here if you understand in detail, in clear, so the 3 control, however we have the 3 program blocks here. I call it as a main program block and the C data control block. There is a C data control block and the C belongs control block. For all the 3 blocks, the address assignment will be carried out by the assembler in the 3 different pieces. Here as a programmer point of view, we might have written together, but address assignment has happened separately. First for the main control section, again sorry for that, main program block, again for the again C data control block, again C blank control block, C blanks program block. So based on this, what is the point you supposed to understand in a sense? What is the starting address for the main control block? It is 0. But what is the ending of the, what is the last address of the main control block in the sense? You can understand it is from 63, and this is what format 3. As it is format 3, so after 63 it will be 66. So remember the last address after the, or you can say last address for the first program block will be 66, wherein the same thing will be used as the starting address for the C data program block. Remember, the starting address for the program block, main program block was 0, whereas the last address for the main program block will be 66, because the here 66 is 63 plus 6, it will be 66, wherein that 66 will be acting as starting address for the second control block, which is C data. So it will start from a 0066. But what about the last address? What will be the last address for the last address for the program block C data? That itself will act as the starting address for the next control block, which is what, C blanks. So based on that, you understand clearly the starting address for the first block, which is 0th block, is the name which is the as usual default, which is the main program block. What is the starting address? It was 0, and totally what was the length? It is 66 bytes. So the last address was 66. So that itself will be the starting address for the next program block, which is C data, which is program block number 1. And till where? What is the length of the program block? What was the length of the program block C data? Here if you observe, so here we had 03, again here is 6, again here 7 till A, and this requires 1 byte, so next will be a B. So the size length will be B. Length will be 0 to A. So that 0 to A, that when you next last address will be B. So as last address will be B, when you add this B to the 66, so the next address will be 71, which is 71. So remember, so the starting address for the program block C blocks, will be a 71, and how many bytes we are allocating, which is, you can observe, 1000 bytes we are allocating. So the length will be 1000. So when you represent in the hexadecimal, it will be a 0 FFEF. So remember here one thing you want to understand, the assembler, what it does in the sense, it has started the address assignment however we do it, you do it. So start from the beginning, you keep allocating start from the beginning for each and every program block separately, which is very, very important. So here 0, again as soon as the new block started, here it has started with the 0. So again here one more block started, so it again initialized to 0, wherein this 24 will be continued here, whereas this 3 will be continued with the 6 here. So like that, there is a necessity of multiple location pointer at the pass 1 of assembler for address assignment. However, I hope you remembered in the pass 1, pass 2. In the pass 1, that is where we do actually address assignment. In pass 2, we do the object code generation. So in pass 1, whatever you have studied till now as only one location counter, so now you need to make sure that you should have the 3 location pointers. So as I have the 3 program blocks in this example, so I need the 3 location pointers. So in general, if your program has n number of program blocks, then you should have n number of location pointers like this. Every time you should have separate location pointer to keep track of the location of the program block 1, 2, 3 like that. If you have n program blocks, so you should have the n number of location pointers, which is very, very important for you guys to know them. Next is as usual, so at the time of address assignment, it will does continuously, wherein at the time of this block address generation, or you can say the block table generation, so it will first you need to identify how many blocks are there, what are the names of them. Then This is what the block numbers. It can be from 0 to n minus 1 for n number of blocks. Then what is the starting address, which will be the main starting address, and the last address for the first program block will be acting as the initial address for the next program block. So that will be continued till the last. So in this example we have the 3 program blocks, and the address, how the addresses will be changed here I shown here. So based on this, try to understand clearly. So what we did, the general program, what we did here in the sense, we made it into the 3 pieces. How? So what are the instructions belongs to the program, this is what the instructions, and these are what the instructions belongs to the data space. Those instructions belongs to the data space we put into the separate program block. As so what happens in the sense, first all these executable instructions will come, for which you need the object codes. So for which you need the object codes, those will come first, then the C data will come. That's what C data program block, which is only reservation. You can observe only reservation instructions. So these instructions will come, C data instructions. What are all the instructions belongs to the C data will come. Then again finally C belongs instructions will come to the picture. So those instructions will be organized such a way that those instructions are organized like this. So if you observe, this was the default program block we had. Then C data first program C data program block, again second again we got C belongs program block. Right after that, this is what the main record we had. If you observe, this is what the main record we had, wherein this is what the second second subroutine, I can call it as a read record. From that again we had the 2 pieces. One is the default program block, and also we had the C data program block. And lastly write record also we had the 2 pieces. One is default program block and the C data program block. Like this we had separately. So now whenever you want to load, this is what I'll explain this further. Whenever you want to load, you can observe first we'll be having all the default, which is the main program blocks. Again we will be having a first program block. That's what, this is what the 0th program block, this is the program block number 1, and this is the program block number 2. So this is how it will be loaded to the main memory. So this is what you had written as a programmer. When it is loaded, this is how it will be loaded. First will be default instructions will come, then again the instructions belongs to the program block 1, again the program block number 2 instructions will come. Now let us see about this part. How does the object code or object program can be generated? The process of generating the object code for each and every instruction is no difference however you followed earlier. What do I mean to say? So here if you observe, so let me take up an example. Let me take up an example of this LDL length. If I take up an example of this LDL length, so as we know that it is a format 3 instruction, so the opcode of LDL is 00. As it is neither immediate nor indirect, so N and I will be 11. As it is not using any X register, so X is 0 and E will be 0, and what will be the base or PC. So for finding out that, so how to find the relative address, which is as usual operand address minus the PC value. But what is the address of this length? Because the length is the operand. What is the address of the length? Here you observe carefully, the length is the parameter, or you can say length is the operand here, which is a variable that is not declared in the same program block, that is declared in the separate program block. If you observe right here, so this length is declared at the separate program block here. So what is the length of the what is the address of the length? Is it 3? No, it is not 3, because the address of the length was 3 when the starting address for the C data was 0. But I said it is changed. What is the starting address of the C data? It is not 3, it is what? 66. When the starting address of the C data is 66, so the addrss of the length will be 69, because 66 plus 3 it will be 69. Now you calculate the length, address of the length is 69. So because the operand here it is length, so address of the length is 69, and what is the PC value? It is what? 9. So 69 minus 9 is 60. This is what the object code you got, which is 032060, which is the object code of the length. Again, if you take up the compare hash 0, you take up the opcode of the compare and try to set the NXBP based, because it is a immediate, and also as it is a direct value, so the address will be, which is target address, will be 0. You can take up any instruction and try to generate however we did earlier. So you can take up any instruction. Let us take up one more example for your consideration, which is, let's take up this JSub write record. If you take up this JSub write record, you as usually set the opcode and the bit fields. What is the address of the write record? There is a address of the write record here. The address of the write record here, somewhere here, as 4D. Address of the write record as 4D, but which is also belongs to the same program block. However, this, so 4D minus 12. So 4D minus 12, which is 3B. So like that, because D minus 2 it is B and 4 minus 1 is 3. So you got as 3B. So like that. So you can generate the object code for each and every instruction based on the previous procedure whatever we followed. And you can generate the object code. Here again we have the format 2 instructions. So you have the opcode and the register numbers, and there is no second register, so it will be 0. It is a general process what we are supposed to follow. Once after you generated the object code for each and every instruction, then now it is the time to write the object program. When you want to write the object program, for this example, you observe. So as we have different, however we have the different instructions belongs to the different program blocks, so even the object code will also vary. How it will vary, let us see now. So here, this is what the main, this is the main object, this is the main program block. You start writing as usual header record, you write, again you write down the first text record, and when I am keep writing as usual by this 010003, the length of the text record, however we know that what is the maximum capacity of or maximum length of the text record, it is 69, and so it has end up. So I need to initialize the new text record. I had initialized and I am just writing till 3F. So right after the 3F, next there is no object code. At the same time, you should also make sure that next instruction itself is the next program block. So you are supposed to stop the current text record there itself. So remember, you are supposed to stop the current text record there itself. Then again you initialize, so there are no more object codes here. So we have the object code here next in the from the address 27. So you start from the 27 and you keep writing. So as soon as you reach to this B850, again as usual you reach to the 69 maximum. It is not 69, it has become 67. So which is obviously you can't have one more object code right there. So you need to stop the current text record there, and you need to initialize the new text record for this. You need to initialize the new text record for these 3 object codes. So initialize the new text record and write those 3 object codes in the current text record. But right after this 4F40, the next instruction is the new program block instruction. So even though you could able to accommodate F1 in the same instruction, but you should suppose not to do it, because the address of this F1 is changed, because this belongs to the different program block. So you stop that control section, sorry, you stop that text record there itself for 4F40, and for just because if this F1 you need to have a separate text record, because that is belongs to the new block, new program block. So you have a separate text record. Again you come back to the program block 0. So we started with the each and every object code. Again as usual, right after this 4F40, even though there is an empty space which is left out in the current text record, so you cannot accommodate this, or you should not insert this in the same text record, because these are belongs to the new program block, because here it is these are belongs to new program block. So you suppose not to include this in the same current text record. You supposed to have a new text record for these. So that is what we do here. And finally it is the end instruction. So based on this, if you observe right here, based on this, as we had a, so start from here, you keep writing, so and also you need to verify that whether you reach to the maximum count of 69 or not. At the same time, you not only bother about 69, you should also bother about whether the further instructions belongs to the same program block or the new program block, like this. If there are the instructions belongs to new program block, which has to be written separately. Now once you have written this program block, now you let me come back to this. So if you observe, I already said, so this is what the main program, this is the source program, and this, in the source program, this is the first you had, this is the default program till here, there's the default program. Then again C data program block has come into the picture, again C blocks has here, again the main default program has come into the picture, again C data is here, again the default is here, and this is what the C data program block, that is what the source program you had written. But when you generated the object program, if you look into there, so this first default itself, you got the two text records, so I can say it as a default 1 and default 2, because you got the two text records for the first default program block itself. So I can say it as a default 1 and default 2. Then again, this is the text record belongs to the, this is the text record whatever we have belongs to the next program block. So here, this is what the default 1 we had, default 2 we have, this is what belongs to the default program block itself, wherein this is what belongs to the, this text record belongs to the C data program block. So that C data program block has a separate text record for that C data program block. Again came to the picture, main blocks, this is the text record belongs to the main block itself. So you'll be having this is the default text record for the default program block. Again finally, this is the code for, this is the text record for the C data, second piece of the C data whatever we had. So this is the C data. So in that perspective, first we'll be having, this is the source program how you had written. When it is stored, when it is generated the object code, you have a separate text record for these, whereas when you are stored, you can observe default, remember default program block will be the first program block, again C data program block, then only the C blocks instructions came to the picture. Now I told you here in the given program, if you observe, there are no format 4 instructions. Why here except this? Here, even though it is a plus JSF read record plus JSF write record, I already said here, which is even though it is a plus JSF read record plus JSF write record plus JSF, even though it's supposed to be plus in a general case, even though it is a JSF, which is for jumping to the subroutine. What is the subroutine? It is the read record, write record. Even though read record and write record are not belongs to the main record, they are the new subroutines or subrecords. Even then, we are not using it as a format 4. It is enough if you make it a format 3. You can fetch the target address of this read record and write record just by using the relative address itself. So it will never be beyond the range of the program counter mode itself, because the read record and write record, you can observe the address of the read record, it is address of the read record and the write record is 27 and address of the write record is 4D, which is when you subtract these addresses with the PC value, per suppose here let us take up an example as JSub write record. What is the address of the write record? It is what? 4D. And what is the PC value? It is what? 12. When you subtract 4D minus 12, you will get as 3B. Take up one more example. JSub read record. What is the address of read record? It is 27. Address of read record is 27. What is the PC value? It is 6. When you subtract 27 minus 6, you will get as 21. So like that. So even though you are jumping to the other subroutines like read record and the write record, but the target address, you are finding it as a relative address, and that relative address will never be greater than the range of your PC mode, or it can be a PC mode. So that is the reason you can avoid the format 4 instructions, and you can also avoid the confusion in the process for the programmer to have all the instructions together. So that is a necessity of, or that is a functionality or usage of the program blocks, where you can divide the complete program into the multiple pieces. You can divide into the multiple pieces and multiple parts. However, we do it manually. In the same way, assembler will also do it manually. My assembler will also consider them it as a independently, 3 independent program blocks. So till here it is a separate program block. From here this next program block, again this is the next program block. This is the code belongs to the main program block. Again these 2 instructions belong to the second program block. So like that it will categorize. Once it will categorize and address assignment is done, then at the time of this, at the time of generating this block table, it will do combine everything such that last address of the main program block will be the beginning address for the next program block, and the last address for the current program block will be the beginning address for the next program block. In that way it will complete the address assignment, and as a part of pass 2 object code generation also, it will carry out normally, however we do it manually. Then coming to the object code generation, object program generation also. So it is, you not only bother about the 69, which is the maximum limit of the text record, you should also make sure that whether the further instructions like this, further instructions belongs to the same program block or different. So this is what the new program block, you suppose not to mix these in the same text record. So because they are in the different addresses, they are not continuous address, because they are going to be located in the different addresses like this. They are not going to be continuous like this. So that is what the program blocks and the importance of the program blocks. Now let us see the program, or I say it as a algorithm about the procedure or the working with this program blocks. So which already has said, you supposed to have multiple location counters for the multiple program blocks. If I have I number of blocks, so you should have I number of location counters. So that is the reason here we are using the location counter of I, and all those location counters for the I number of program blocks, we are initializing the starting address as 0. And for the block number 0, so as it will be for the first block, the block number will be a 0. So we are initializing the block number as 0, and the location counter for all the blocks will be 0. Then you start with the first instruction and keep performing the operation of address assignment. So before you take up the address assignment, this is the additional part which we are seeing here in this algorithm, as if you have the opcode as use. If you have the opcode as use, which already said, with the use, if there is any operand name, then it means to say that there is a new program block which you are supposed to create. If there is no name, that is what, even though if there is a opcode as use and if there is no operand name, then you are supposed to consider the further instructions as the default program block. If there is a name, then you are supposed to consider the name in the operand as the block name. And if there is a program block name, you're supposed to store that to the block table, I can say. So whenever you want to insert that to the block table, how you supposed to insert it is the block name with the block number. Earlier the block number was 0, now it will be incremented to plus that's what it will become 1, which that will be stored to the block table. And this will be done only if the block name which is not available already in the block table. If it is there, if the entry is already found in the block table, then you will never do this because it's already available. And so that's how you will be incrementing and storing that to the block table. And the rest of the algorithm, which is already known part, which is if there is a symbol in the label field, so obviously you will be searching in the sim tab for the label. If it is available, you will be raising the duplicate error. If not, you will insert that label with that location counter address. If you observe right here, it is not location counter address only, it is a location counter of I, because that I will be varied based on the program block. That will be address you will be inserting to the sim tab. If not, how to vary the addresses? So how to vary the addresses? It is as usual. For every instruction you will be adding 3, because all the instructions will be considered as a format 3. Then per suppose per suppose if it is a word instruction, so we'll be adding 3 because word requires 3 bytes. If it is reserve word, so it will be the operand into the 3 because so many words you need to reserve. Again, if it is reserve byte, the operand value itself. If it is byte, first you need to find out the constant length that you will be adding to the location counter. So that is the normal process which we had in the earlier algorithm also. Here, so here the extra thing which is supposed to know is that, so you do deal with the program block. And how do you deal if there is a use keyword? So check whether there is a name with that use keyword. If there is no name, then consider that as a default program block. If there is a name, check that name is already available in the program block table. If it is already available, then you are not supposed to add it again. If it is not available, then you are supposed to add it again and keep incrementing the location counter value. And so address, the last address of the current program block will be the starting address for the next program block. That is also extra thing which is supposed to know here. So that is what the pass 1. What happens in pass 2? However, the object code generation, this also we had with the algorithm whatever we had earlier. Here is an advancement, as here only the one thing which is advanced. So do we need to generate any object code for the instruction which has the opcode as use? In a sense, no, you are not supposed to generate the object code, but you need to fetch the address of that particular program block. That is only the advanced three lines of extra algorithm which you are going to have with the pass to assembler algorithm which we had earlier. So this is all about the program blocks. Thank you.